Section 5.6 is on radical expressions. I am going to do 6 problems from your homework assignment. Number 16 is the square root of 72. Break that up into your largest perfect factor and then your other factor. The largest perfect square in 72 is 36. The other factor would be 2. Take the square root of 36, which is 6, times the square root of 2. With number 20, you're looking for perfect cubes. So we're going to split this up into your largest perfect cube factors, other factors. 16 is not a perfect cube, but 8 is. So 8 times 2 gives us 16. Y cubed is a perfect cube, so we put it underneath the radical. That is the perfect radical. Take the cube root of 8, which is 2. The cube root of y cubed is y. And again, the shortcut is taking your power divided by your index. Then you just multiply by your non-perfect factors and you are done. Number 26 is the 5th root, and we want to divide a fraction, because it is a fraction, into 2 pieces, the top part and the bottom part. The top part is w to the 6th power z to the 7th. The bottom part is 32. The denominator comes out nice because the 5th root of 32 is 2, because 2 times itself 5 times gives you 32. In the top, not everything underneath the radical is a perfect fifth. So what we do is look at w to the 6th, and if you take 1 power less, which is w to the 5th power, that is a perfect fifth. And w to the 5th times w gives you w to the 6th. W to the z to the 7th power is not a perfect fifth, but z to the 5th power is. Z to the 5th times z squared gives us z to the 7th power. The last part of this is take the perfect factors, the perfect fifths, and take the 5th root of them. The 5th root of w to the 5th is plain old w. 5th root of z to the 5th is z, times the 5th root of wz squared, all over 2. Then that is your final answer. The next problem I'm going to do is number 36. 36, we want to simplify by adding and subtracting radicals. The only way to do that is if the numbers underneath the radical are the same. These are all different, but they all have some perfect squares in them. With 98, the largest perfect square in 98 is 49 times 2 gives us 98. In 72, 36 is the largest perfect square. 36 times 2 gives us 72. The square root of 32, 16 times 2 gives us 32. Then take the square root of those perfect factors. Square root of 49 is 7 times the square root of 2. The square root of 36 is 6 times the square root of 2. The square root of 16 is 4 times the square root of 2. And because all numbers are the same underneath the radical, those are like terms. 7 minus 6 is 1. 1 plus 4 is 5 times the square root of 2. Number 40 is a binomial times a binomial, so we have to FOIL. 3 times 2 gives us 6 for the F of FOIL. 3 times the square root of 6 gives us 3 times the square root of 6 for the outer of FOIL. The inside of FOIL, square root of 7 times 2 is 2 times the square root of 7. The L of FOIL is square root of 7 times the square root of 6, which is the square root of 42. Looking for perfect factors underneath the radical. Okay, so with this problem we are done because there are no perfect factors in 6, 7, or 42. These are all unlike terms. The last problem we're going to do is one that involves conjugates. The square root of 6 and the square root of 3 contains no perfect factors, but we have a radical in the denominator. The conjugate of the denominator is 5 minus the square root of 3. And what we do to the denominator, we need to do to the numerator. All a conjugate is taking the opposite sign of what is in between the two numbers. In the denominator, if we FOIL the denominator, we have 5 times 5, which is 25. The outer, positive square root of 3 minus the square root of 3 is minus 3. The inner of FOIL is square root of 3 times 5. The inner of FOIL is 5 times the square root of 3. I did go a little out of order here. I did do the F of FOIL and the L of FOIL and then the inner of FOIL. So I am going to pick up now and do the outside of the outer terms of FOIL, which is 5 times a negative square root of 3, which is negative 5 times the square root of 3. And what happens is that the outer and the inner cancel off, and you're left with 22. The numerator, we do not use the FOIL, we distribute square root of 6 times 5, which is 5 times the square root of 6. Then take square root of 6 times a negative square root of 3, which is negative square root of 18. Now, in 18, there is a perfect factor of 9 times 2. So that does simplify to 3 times the square root of 2. So our numerator is going to be 5 times the square root of 6 minus 3 times the square root of 2. This is our final answer.